Dear students, welcome to our class on JRF, SRF NET 2022 Agricultural Meteorology Advances 1. In this class, we try to understand the advances from your examination point of view. See, when we talk of agricultural meteorology, advances in general meteorology, advances in general climatology, advances in agricultural climatology, advances in micrometeorology, climate change, or evapotranspiration, weather forecasting for agriculture, and some other disaster management techniques, and from your examination point of view, some bits are essential. Okay, so we try to understand slowly one by one the advances. See, actually, micrometeorology. When we talk of micrometeorology, the climate of a cropped field, we call it as micrometeorology. The climate of a cropped field, we call it as micrometeorology. What is meteorology? Meteorology is the study of the science of atmosphere. Micrometeorology means the meteorology or the climate of a cropped field. Now, here, when we try to understand micrometeorology in an advanced courses, because this is the advances one, I would like to impress upon you that the advanced definition of micrometeorology is study of those aspects of meteorology. So I defined half minute back what is meteorology. Meteorology is the study of the science of atmosphere. So micrometeorology in advanced definition is the study of those aspects of meteorology that have direct relevance to agriculture. If we stop there, it is agricultural meteorology. Okay, meteorology, micrometeorology, agricultural meteorology. So once you see these three, what is agricultural meteorology? Study of those aspects of meteorology that have direct relevance to agriculture. Now, micrometeorology definition in advanced stage, after knowing what is meteorology, what is agricultural meteorology. Now, micrometeorology has been defined as the science concerned with detailed examination on the micro scale basis of the meteorological and, please see the word here. Advanced definition of micro, this bit will come, that's why. Advanced definition of micrometeorology. Micrometeorology has been defined as a science concerned with detailed examination, on the meteorological basis of the physical factors that are taking place within the ecosphere. That are taking place within the ecosphere. See the advanced definition. First phrase only. Again, for your academic interest, meteorology is the study of the essence of atmosphere. Agricultural meteorology is the study of those aspects of meteorology that have direct relevance to agriculture. These two bits may come in JRF level, no advanced level. Micrometeorology different. The climate of a cropped field is micrometeorology, that is at the JRF level, no SRF level. Micrometeorology has been defined as the science concerned with the detailed examination of the microscale basis of the physical and meteorological factors that are taking place within the ecosphere. See, here the word ecosphere has come in the advances. That is what you, my beloved students at the PG and PhD level, shall understand. So, for my satisfaction and to enlighten you all, I would like to impress upon you that the definition of micrometeorology includes a term called as ecosphere. Here, what is the ecosphere for micrometeorological studies? So, Micrometeorology is one of the subjects of our agriculture meteorology. Now, in the micrometeorology, by definition, advanced definition of micrometeorology is study of those aspects of micrometeorology has been defined as the science concerned with detailed examination on the basis of physical and meteorological factors that are taking place within the ecosphere. Now, ecosphere, this bit will come. Here the ecosphere is, if it is a forest land, just below the root zone of a tree and just above the tree in forest. If you take a paddy crop, if you take a maize crop, if you take any cereal, pulses, oilseed crop, just below the root zone, just above the crop zone, just below the root zone, just above the crop, we call it as the ecosphere. This bit also may come. Now, there is a term called as ecoclimate. There is a term called as ecoclimate. What is ecoclimate? Here, very interesting. The climate within the ecosphere is known as ecoclimate. The climate within the what is ecosphere here? Ecosphere for the forest, okay, just below the root zone, just above the tree. As far as our cereals, pulses, oil seeds are concerned, okay, just below the root zone, okay, just above the crop, whether it is cereals, pulses, oil seeds, commercial crop. Now, after understanding this one, what is ecosphere? I told. What is ecoclimatology here? What is ecoclimatology? Wonderful thing here. So, ecoclimatology is the climate just below the root zone, just above the crop in case of agriculture crops, just below the root and just above the tree in case of forest crop, and for animals, the just below, just where the animals touch the foot with the surface and just above it, we call it as the ecoclimate. Ecoclimate of crop, ecoclimate of forest, ecoclimate of animals. So these bits will come. So we start advances from here. Now there is a bioclimatic law. What is that? There is a bioclimatic law. This was introduced in the year 1928 by Hopkins. It's a wonderful law. It is not a concept, it is a law. It is a by law. Okay, what is that law? In the America, Northern America, that is USA, okay, Northern America, above the equator, okay, Northern America. What is Southern America? Southern American countries are Brazil, Venezuela, Peru, Chile, Argentina. These are all the northern Chile, okay. These are all the Mexico and okay, border below the equator. Now, in the Northern America, the last bioclimatic law. This bit will come that way. What is bioclimatic law? For every 1 degree latitude towards the northern side, for every 1 degree longitude towards the east side, and for every 400 feet, there is a 4-day lag in the crop phenology. In the crop lag, that's what we call it. So what exactly does it mean? A place is there at 20 degrees latitude, say for instance, for example, 20 degrees latitude, say 100 longitude, say 1200 meters, okay, 1200 feet above the mean sea level, average mean sea level. So what happens? There is a lag of 4 days. A crop is maturing in 120 days at 20 degrees latitude. So at 21 degree latitude, okay, and the height increase of 400 feet, and 1 degree longitude, another location is there. There the crop matures in 124 days. So these are the fundamentals for our agricultural meteorology to make a beginning in the advances. So meteorology, agricultural meteorology, micrometeorology at the UG level, micrometeorology at the advanced level, advances, and what is ecosphere, what is ecoclimate, what is bioclimate law. So here, Now, very interesting thing is in the micrometeorology, the very interesting phenomena are three transport processes. Very interesting phenomena are three transport processes. So, what are the three transport processes? The first one is the mass flow or mass diffusion or fluid flow. Fluid flow. Let us start. Let us talk about only two terms. Fluid flow, okay? Fluid diffusion. Fluid flow, fluid diffusion. It is given by Newton's law of viscosity. Once again, for your academic interest, the fluid flow and fluid diffusion, okay, almost similar. They are complementary. They are explained in the micrometeorology for for micrometeorology students of PhD and PhD level. It is explained by Newton's law of viscosity. Now, second thing, Fick's law of diffusion. Actually, what mass flow? Mass flow means, if you take say a perfume is there. A perfume, you are spreading perfume. Your small gun is there. So you release the perfume. It goes from higher concentration to lower concentration. Fluid flow, Newton's law, from higher velocity to the lower velocity. Okay, the fluid flow. So fluid diffusion we call it as. Now the mass flow, that is momentum flow also. Which one? Newton's law deals with these three terms are same. Fluid flow, momentum, or fluid diffusion, mass diffusion, or fluid diffusion. Once again, I will tell. Newton's law explains us. What is Newton's law? I will give after a couple of minutes. Newton's law explains the fluid flow. Okay, Newtonian, non-Newtonian fluids are also there. They are covered in the theory in my earlier lectures. From BIT's point of view, I am telling. So, three transport processes are there in the micrometeorology. We should understand. As agrometeorology, PG and PhD, we should understand. Now, Newton's law of viscosity explains us, okay, momentum, fluid flow, okay, fluid flow, momentum. Now, second thing is Fick's law of diffusion, F-I-C-K-S, Fick's law of diffusion. It deals with the mass flow or mass diffusion. What is mass diffusion? Weight, by mass means weight. So, if I put some perfume at the corner of my room, our classroom, so it spreads. Fick's law explains that one. The third one is the Fourier's law of thermal diffusivity or thermal conductivity, anything we call it as Fourier's law. So, what is the Fourier's law of diffusivity or conductivity? The heat flow, the electrons flow from high concentration to lower concentrations. Now, here I would like to share with you some of the most important things. The three fundamental laws for transport processes. The three fundamental laws for transport processes are, okay, first one, fluid flow or viscosity or momentum diffusion, Newton's law. Conduction, mass transfer or matter diffusion, Fick's law. Conduction or thermal diffusion, Fourier's law. So, what is rate of transport? What is rate of transport? This bit will come. What is rate of transport? Rate of transport is driving force divided by resistance is the rate of transport. Three transport processes are there. Newton's law, Fick's law and Fourier's law. So these are all transport processes. Now here, the rate of transport. What is the meaning of rate of transport? To driving force by resistance, we call it as the rate of transport. Transport phenomena relate to the tendency of transport phenomena relate the tendency of velocity. Tendency of velocity in Newton's law, the tendency of concentration in case of Fick's law. So higher concentration to lower concentration diffusion occurs like perfume, The tendency of velocity is explained in case of Newton's law. These bits will come. The tendency of temperature is explained in case of Fourier's law of diffusion or thermal diffusion or conductivity. Now here the definition of only 3 definitions I will give and I complete today's class. Now momentum diffusion or viscosity, momentum diffusion or fluid flow or viscosity, Newton's law. What Newton's law says? Newton's law of viscosity states that the shear stress between fluid layers is proportional to the negative value of velocity gradient between 2 layers. If you take a book like this, if you just swing it, if you take a book and move it, so that's what we call as the shear stress of that book. Okay. Similarly, the Newton's law states that Newton's law of viscosity states that the shear stress between fluid layers is proportional to the negative value of velocity gradient between the 2 layers. So this is the definition of Newton's law. This may come in any form of in the bit. Last 2 definitions I will give and I complete today's class. The diffusion, fixed law of diffusion. What is fixed law of diffusion? Mass transport is generally referred to diffusion. This bit will come. Mass transport is generally referred to as a diffusion. Now, the fixed law states that the spreading of mass from high concentrated areas to less concentrated areas is diffusion or mass transport. So, simple. As I said, the Newton's law is the tendency of velocity, mass the tendency of concentration. These bits will come. Mass tendency of diffusion, mass the tendency of concentration, mass the tendency of concentration. Newton's law, the tendency of velocity. The last one is the Fourier's law. What is Fourier's law? Here the Fourier's law states the rate of heat transfer. The rate of heat transfer through a material is proportional to the negative gradient in the temperature and to the area at right angles to the gradient through which the heat flows. Once again I read and complete today's class. The rate of heat transfer through a material is proportional to the negative gradient in the temperature. Okay, from one side to other side. If you take a wall, okay, here 40 degrees, that side 35 degrees. So negative gradient, 40 to 35 gradient is there. Now, the rate of heat transfer through a material is proportional to the negative gradient in the temperature and to the area of the wall at right angles to the gradients through which the heat flows. So that means if I take this paper, okay, the paper, this side temperature is 40, this side temperature, presume that this is 38. There is a difference of 2. What is the Fourier's law of Fourier's law of thermal conductivity or thermal diffusion says negative gradient of temperature, okay, from higher temperature to this lower temperature, concentration gradient in case of mass. Here heat transfer from one side to other side and area, it is okay, area, negative gradient of temperature and area. This is what we call it as the Fourier's law of diffusion. So here another important point is right angle. What is right angle? Exact right angle, not in a slanting way. How the heat is flowing from, presuming that this is a wall. So from the wall, from this side to that side, it depends upon the thermal coefficient of thermal conductivity of this particular. If it is a brick wall, if it is a thermocol, okay, depending upon that coefficient of diffusion of that particular material which is used for the wall plays an important role. So all these come in the form of bits. This is what I would like to share with you in Advanced S1. We move forward with more advanced classes.